This is my fourth video lesson for Unit 7. In this lesson, we'll be learning how to apply the heat equations. Go to page 18 in the class packet. If you recall from previous PowerPoints, heat and temperature are determined differently. Temperature can be measured directly using a thermometer, while heat cannot. We will be calculating heat indirectly using the heat equations on Table T. Learning target. At the end of the lesson, I'll be able to use heat equation to calculate heat and temperature. Homework be number 4, which will be a junior pod based off this lesson. The heat equations can be found on Table T on your reference table. There are 3 of them, and we're going to analyze each one. The symbol Q stands for heat. The unit of heat is joules or calorie. Table T tells us information about the heat equation. Table D tells us the unit. The symbol M stands for mass. The unit of mass is grams or kilograms. HF is the heat of fusion, is the amount of energy needed to melt a given mass of a solid at its melting point. The unit of heat of fusion is joules over grams. The heat of fusion of water can be found on Table B on your reference table. HV is the heat of vaporization. It is the amount of energy needed to vaporize a given mass of a liquid at its boiling point. The unit of HV is joules over gram. The heat of vaporization of water can be found on Table B on your reference table. C is the specific heat capacity. It's the amount of energy to raise the temperature of 1 gram of the substance by 1 degree. The unit of specific heat capacity is joules over grams times Celsius or joules over grams times Kelvin. The specific heat capacity of water can be found on Table B on your reference table. Delta T is the change of temperature, T final minus T initial. The unit of temperature can be Celsius or Kelvin. Table B on your reference table lists out the physical constants for water, the heat of fusion, and the heat of vaporization, and the specific heat capacity of water. If the heat questions on the regions involve water, you have to look up these constants on Table B on your own. If the substance is not water, it will be given to you in the question. When to use these equations, you want to look for keywords in the heat questions on the regions. If you see the following keywords, melting, fusion, freezing, 0 degrees Celsius, water solid to water liquid or ice, you use this equation. Q equals mHF. HF can stand for heat of fusion or heat of solidification. If you see these keywords, boiling, vaporization, condensation, 100 degrees Celsius, water liquid to water gas, or steam, you use this equation, Q equals mHV. HV can stand for heat of vaporization or heat of condensation. If you see these keywords, change in temperature to different temperature, or temperature increasing or decreasing, you use Q equals mc delta T. If your heat question involves a heating curve, here is when you use this equation based off the interval. Notice when the line is sloped, when the temperature is changing, you use Q equals mc delta T. When the line is flat and the temperature is constant, you do not use Q equals mc delta T. During melting, you use Q equals mHF. During boiling, you use Q equals mHV. Check of understanding number 1. Which substance needs more energy to raise the temperature by 1 degree? Assume the same mass, and why? So notice we're given 2 substances, oil and water. Notice that water has a higher specific heat. Therefore, it takes more energy to raise the water's temperature than the oil's temperature. Why is that? If you were to raise the temperature of 1 gram of water by 1 degree, you would need 4.18 joules. If you were to raise 1 gram of oil by 1 degree, you would need 1.67 joules. So you can see that water would need more energy because of higher specific heat. Learning check number 2, which is a better conductor of heat, oil or water? So again, we have to analyze the specific heats of oil and water. Since oil has a lower specific heat, it takes less heat to raise the temperature of oil versus water. So a substance with a low specific heat is a good conductor of heat because it will require very little heat to heat up the substance. Learning check number 3. Why is heat of vaporization generally greater than heat of fusion if solid has the highest intermolecular force? Here are the particle diagrams of solid, liquid, and gas. From solid to liquid, that is melting, and we use heat of fusion. From liquid to gas, that's boiling, and we use heat of vaporization. If we look at the particle distance, from solid to liquid, the particles move slightly apart, but from liquid to gas, they move far apart. Therefore, more energy is required during boiling because the particles move much further apart from liquid to gas than during melting from solid to liquid. Check of understanding number 4. Since heat of vaporization is greater than heat of fusion, how is it shown on a heating or cooling curve? So here we have a heating curve. Since heat is added at a constant rate and boiling takes more heat than melting, on the heating curve, boiling, which is represented by interval D, should be longer than melting, which is represented by interval B. Learning check number 1. Based on this graph, what is the heat of vaporization? Pause the video and resume once completed. Heat of vaporization is during boiling, so interval DE. The amount of heat in interval DE is 400 calories, so the answer is choice 3. Learning check number 2. The strongest intramolecular forces of attraction exist in a liquid whose heat of vaporization is what? Pause the video and resume once completed. Heat of vaporization is the amount of energy it takes to vaporize a substance. So the stronger the intramolecular force, the more energy is required to vaporize the substance. So the answer is choice 4. Learning check number 3. What accounts for the fact that segment CD is longer than segment AB? Pause the video and resume once completed. Segment CD represents boiling, AB represents melting. Boiling requires more energy than melting, therefore the heat of vaporization is greater than the heat of fusion. Now we're going to go over some questions involving the heat equations. Question 1. In a household radiator, 1,000 grams of steam at 100 degrees Celsius condenses, changes from a gas to a liquid. How much heat is released? On table T, there are 3 heat equations. We have to look for keywords to figure out which one to use. The keyword is condense, which tells us that we should use Q equals mHV. The question is asking for heat. The symbol of heat is Q. M is mass, which is 1,000 grams. HV is the heat of vaporization. The heat of vaporization of water can be found on table B on your reference table. If we plug it into the equation, we get 1,000 grams times 2,260 joules per grams, and we get heat as 2,260,000 joules. Question 2. How much heat is required to warm 275 grams of water from 70 degrees Celsius to 87 degrees Celsius? Since there's a change in temperature, we have to use the equation Q equals mc delta T. In this question, we're solving for Q, which is heat. We're given the mass, which is 275 grams of water. C is the specific heat of water. You can look that up on table B in your reference table. Delta T is T final minus T initial. That'll be 87 minus 76. So once you plug into the equation, you use your calculator and solve for Q. We get Q as 12,644.5 joules. Learning check number 4. The temperature of a sample of water changes from 10 degrees Celsius to 20 degrees Celsius when the water absorbs 100 calories of heat. What is the mass of the sample? Pause the video and resume once completed. Since there's a temperature change, we have to use Q equals mc delta T. We're solving for mass. We're given Q as 100 calories. Delta T is T final minus T initial, so 20 minus 10 is 10. C is the specific heat of water. If you look on table B on your reference table, is 4.18, but since we're given calories, we need to convert joules to calorie. We know 4.18 joules is 1 calorie, so the specific heat of water in terms of calorie is 1. If we plug it into this equation, we get the mass as 10 grams. Learning check number 5. How many joules of heat energy are released when 50 grams of water are cooled from 70 degrees Celsius to 60 degrees Celsius? Pause the video and resume once completed. Since it's a temperature change, we have to use Q equals mc delta T. In this question, we're solving for heat energy, which is Q. We're given mass, which is 50 grams of water. C is on table B on your reference table, and delta T is the change in temperature. If we plug it in, we get the answer as choice 3, 2,100 joules. Learning check number 6. What is the minimum amount of heat required to completely melt 20 grams of ice at its melting point? Pause the video and resume once completed. The key word is melt, so we have to use the heat equation Q equal mHF. We're given the mass as 20 grams, and HF is found on table B on your reference table. HF is 334. 334 times 20 give us 6,680 joules. Learning check number 7. What's the total amount of heat required to vaporize 1 gram of water at 100 degrees Celsius and 1 atmosphere? Pause the video and resume once completed. The key word is vaporize, so we have to use the equation Q equals mHF. M will be 1 grams. HF, you gotta look on table B on your reference table, which is 2,260. So 2,260 times 1 will be 2,260 joules. Learning check number 8. An 80-gram sample of water at 10 degrees Celsius absorbs 1,680 joules of heat energy. What is the final temperature of the water? Pause the video and resume once completed. Since the question is asking for temperature, we have to use the heat equation that has temperature in it, which is Q equals mc delta T. In this question, it's asking for final temperature, so we're solving for TF. In the question, we're given Q as 1,680 joules, M is 80 grams, C, you have to look on table B in your reference table, it is 4.18, TF is what we're solving, TI is 10 degrees Celsius. If we plug it in and solve for TF, we get the answer as choice 2, 15 degrees Celsius. This concludes the video lesson. Remember to do the Junipod homework.